Hello everyone, welcome back. We're going to talk about using RAM, which is rectangular approximation methods, and trapezoids to represent net change. This goes with sections 5.1, 5.2, 5.3, and 7.6, but in reality, this is kind of the most important topic in Chapter 5. So let's talk about this. I know we've talked about it in class, but a little review. Integration as net change. The integration is the inverse of the derivative, so they're the opposite of each other, working backwards from the derivative. It represents net change over time, so how much something has changed over a given amount of time. Graphically, derivative is slope, integration is area. Well, we're going to use rectangles or trapezoids to approximate this area, depending on what the problem asks of us. So I need to know how to find the area of a rectangle. If you don't know the area of a rectangle, this is probably not the right class for you. It's base times height. However, the area of a trapezoid is a little different. That's the formula. Remember, these are sideways trapezoids. They look like this, which means that the bases are really the y values, and the height is really the x value. Okay? Let's talk about net change versus total change, and I only bring this up because it's so commonly confused. An integral only tells you the net change, not the total change. For example, if you take 5 steps forward, 1, 2, 3, 4, 5, and 2 steps backwards, 1, 2, your net change is only 3 units, even though you've taken 7 steps. Why is that? What messes this up? The -2. The negative numbers mess with total change. In terms of position, an integral tells you how far you are from where you started. Not how far you've traveled, but how far you are from where you started. That's called the displacement. In order to find total change, let's get rid of the negative numbers. So anything that you see that's a negative number, we're going to treat it as a positive number. Now we're doing total change, not just net change. How do I integrate a derivative? Well, most of these problems will be a derivative. You'll know it's a derivative because the units will be something per something, or something over something, like miles per hour, or inches per minute, or people per day, or something. It'll be a rate. When you integrate, you work backwards from the derivative. So let's think about velocity. If I integrate velocity, what do I get back to? I get back to position, because the derivative of position is velocity. Let's say velocity was in miles per hour. If you integrate miles per hour, you're back to position, which is miles. That means that that integral is how far you are, your displacement, in miles over however many hours you integrated for. It'll make sense in a minute. These problems are extremely common on the AP test. In fact, every single AP test I've ever seen has at least one of these, usually more. There's always one of them on the short answer. There's usually one on the calculator multiple choice. So become friends with it. We will do a lot of these. For today, we're only going to do 2. Water is leaking from a 20,000 gallon pool. Over time, the hole increases, which makes the water leak faster. LT is how fast the water is leaking out of the pool, measured in gallons per hour. Okay, let's stop for a second. If I use RAM, that means I'm integrating. So, this is the symbol for integration. If you integrate gallons per hour, you're going to get back to gallons. Be careful, because that's going to become tricky in a minute. Using LRAM and 5 subintervals, how much water has leaked out of the pool over 12 hours? So, let's split it into 5 rectangles. Okay? The first rectangle has a base that is 1 wide, and the left side is 10. Plus, The second rectangle has a base that is 2 and a left side that is 12. The third rectangle has a base that is 1 and a left side that's 17. The fourth rectangle has a base that is 3 across and a left side of 25. And the fifth rectangle is 5 across and a left side of 75. You can use your calculator to add all those up, and you're going to get 501 gallons. Okay? That's the major part of this problem. But let me ask you, is this an overestimation or an underestimation? Well, if you think about what the graph is looking like, what's my graph doing? Is the water leaking faster or slower? It's leaking faster. So that's what the graph would look like. The water's leaking faster over time. If you used the left side of your rectangle, so those are my rectangles. Are those rectangles, the area of these rectangles less than the area of the under the curve, or more? They're less because they're not taking into consideration those little pieces right there. So this is an underestimation. Don't get lazy. LRAM is not always an underestimation. Depends on what the graph looks like. Now let's use RRAM in 4 subintervals. How much water has leaked out of the pool in 7 hours? So let's break it into 4 rectangles. 1, 2, 3, 4. I don't go further because I don't care about the 12th hour. I want 7 hours. So let's use RRAM in 4 subintervals. The base here is 1. The right side is 12. The base here is 2. The right side is 17. The base here is 1. The right side is 25. The base here is 3. And the right side is 75. If you add all of those up, you're going to get 296 gallons. Now let's be very careful and understand what that 296 gallons means. This is why these problems are difficult on the AP test. Not because the math is hard. The math is very easy. But what does that mean? That 296 gallons is how much it has changed. In other words, it's how much the water has leaked out. I didn't ask you how much water has leaked out. I asked you how much water is left in the pool. Well, I started with 20,000 gallons. I've lost 296 gallons. That leaves me with a total of 19,704 gallons left. Be very careful what they ask you. In that problem, just doing the RAM does not get you the answer that they want. They want you to use that to figure out what's going on. Part C, use trapezoids in 3 subintervals. How much water is left in the pool after 4 hours? So, 3 subintervals. 1, 2, 3. Trapezoids this time. Base 1 plus base 2 over 2 times height. Remember, the bases are the y values. So for my first trapezoid, it's 10 and 12. Divided by 2, the height is how wide it is. 1. For the second trapezoid, base 1 and base 2, the height is how wide it is. For the third trapezoid, base 1 and base 2 are the y values, as always. Over 2. The height in this problem is the width there. It's 1. I'll save you some calculations. That's 61 gallons. That's the change. In other words, that's how much has leaked out. Again, the question did not ask how much was leaked out. It asked how much is left. Well, I started with 20,000 minus 61 gallons is equal to 19,939 gallons left. I should be very specific here. After 4 hours. Just like back here, I should have said there's that many gallons left after 7 hours. This is over time, over the first 7 hours. In this problem, over the first 4 hours. Okay? That's using LRAM, RRAM, and trapezoids to approximate change, and then using the change to answer the question. Different problem. A hiker is traveling a trail. After a few minutes, he realizes he forgets his canteen and goes back to his car to get it. His velocity, measured in feet per minute, is listed below. Estimate the acceleration at 20. I have velocity. I want acceleration. Well, how do I find acceleration given velocity? It's the derivative of velocity. But I can't take the derivative of just a bunch of numbers. But what does derivative mean? It means slope. So if I want to find the slope at 20, 20 is somewhere in here. I need 2 points to find that. Well, I'll use these 2 points. What are those 2 points? They're 15, 225 and 25, 175. Find your slope. 225 minus 175 over 15 minus 25, and that is equal to -5. What's the units for acceleration? In this case, it's feet per minute squared. Not an integration problem, not a RAM problem, not a trapezoid problem. It's a physics problem, just recognizing what's going on. B, use LRAM with 3 subintervals. Estimate how far the hiker is from where he started after 90 minutes. So I want change, which is good. 3 subintervals. 1, 2, 3. Uh-oh, that only takes me to 25 minutes. So how could I do this? Well, what if I did bigger rectangles? There we go. Now I have 3 subintervals. I'm using the left side, so the base from here to here is 15. The left side's height is 150. The base from here to here is 25, and the left side's height is 225. The base from here to here is 50, and the left side height here is 150. Add all that up, and you get 15,375 feet over 90 minutes. So he traveled 15,375 feet over 90 minutes. That's about 2.912 miles, just in case you're curious. Which is realistic. If you walk for an hour and a half, you can probably go more than 3 miles. Is this a good estimation, though? This isn't part of the question, but I'm going to ask it. Is this a good estimation? No. What in my data that I used did I omit that is important to this situation? This right here. At no point in my calculations did I take into consideration the fact that he went backwards for some time to get his canteen. So, did I do anything wrong? Absolutely not. Everything is completely correct. I just didn't do a very good approximation method. I did what they told me to, but it's not very accurate. Using RRAM and 6 subintervals, let's estimate how far the hiker traveled. I want total. I don't want I don't want a change, net change. I want a total change, which means that I want to do absolute value of all of these. 6 subintervals means I'm going to use all of them. A lot of calculations here. The first one, the base is 10, and the right side is positive 200. Remember, I'm using the absolute value plus 5 times 225 plus 10 times 175 plus 15 times 150 plus, I gotta go down here, sorry, 20 times 200 plus 30 times 100. If you plug all that into a calculator to figure out what it is, you're going to get 14,125 feet traveled in those 90 minutes. That's the total distance he traveled. Not how far he is from where he started, because he had to go back and get his canteen. In case you're curious, that's 2.675 miles. Which again, realistic for that hiker. Okay? I did absolute value because I wanted total. Using trapezoid with 6 subintervals, estimate the hiker's displacement over 25 minutes. I can't do this problem. Why not? Because I only have enough data to do 3 subintervals. I'm sure I meant 3 subintervals, so let's pretend like this says 3 subintervals. 3. Okay. So, first one, second one, and third one. So, trapezoids. Base 1 and base 2 are 150 plus negative 200 over 2 times 10 plus negative 200 plus 225 over 2 times 5 plus 225 plus 175 over 2 times 10 again. Grab your calculator, crunch some numbers. If you do that, you're going to get 1,812.5 feet. Why is that such a much smaller number than what we did earlier? Because that's only over, what, 25 minutes. That's his displacement. That's not how far he traveled. That's how far he is from where he started. Okay? That wasn't a problem where I wanted total distance. If I wanted total distance, I would have made that and that positive. Big concepts there, guys. Really important problems. We're going to do a lot of them as the year goes along. So if you have trouble with them, come talk to me. It's a reading test. You have to be able to understand what the questions are asking. Okay, thank you.